Hello guys, so in this tutorial we will be seeing the use case of summarization using LangChain. Okay, suppose you have a set of documents like PDFs, Notion pages or customer questions and you want to summarize the content. Okay, so in this walkthrough we will be covering how to perform the document summarization using LLMs. So a central question for building a summarizer is how to pass your document into LLM's context window. So there are two common approaches used for this. So one is like stuff. So simply stuff all the documents into a single prompt. So this is the simplest approach, and where you can use create stub document chain constructor, which is used for this method. And the second one is like map reduce, where you will summarize each document on its own in a map step and then reduce the summaries into the final summary. So we will be using map reduce document chain. Okay, so in the following session, we will be seeing the architecture of these two approaches, and then we will be also seeing how to implement it using LangChain. Okay, so let's dive in.
So let me give the overview for the text summarization. So it's an NLP task that creates a concise, informative summary of a longer text, and LLM can be used to create summaries of news articles and then research papers, technical documents, and other type of text. So summarizing large documents can be challenging. To create summaries, you need to apply summarization strategy to your indexed documents. So in the upcoming notebook that we're gonna see in this tutorial, we will use LangChain, a framework for developing LLM application, to apply some summarization strategies. Okay, so the notebook will cover several examples of how to summarize the large documents. So the objective of this tutorial is we will learn how to use LangChain with OLLM Mistral to summarize large documents by working through the following examples. For example, you will be seeing the stuffing method, map reduce method, and then refine method. Method which involves combining all your documents into a single prompt and then passing it to a a large language model to summarization. So this step is simple approach, and it is suitable for summarizing a small number of documents or when the total size of the document is manageable. And the second method is map reduce. So it involves summarizing each document individually, so in the map step, and then combine these summaries into your final summary in the reduce step. So this approach is more scalable and can handle large volume of text. So third one, we don't have the illustration here, but yeah, the refine method, so which will iteratively update the answer by looping over the input documents. For example, each document it passes the non-document input and the current document and then the latest intermediate summaries to the LLM chain to get the new summary. So this method is useful for refining the summary based on the new context. See how we can just practically implement all these three methods using LangChain. Okay, so for the first time we have to import all the libraries. So let me import all the libraries that we need to implement the summarization using LangChain. Let me select my environment. Yeah, so once it's done, we need to load the pre-trained text generation model, which is LLM. Here we will be using OLLM, so we will use Mistral for the summarization purpose. So to load the LLM, I have to use OLLM from LangChain community, and you can import the model Mistral, and we will be streaming the output. What we have to do is we have to prepare the data files. So to begin, we will need to download few files which we need to summarize. Okay, so for that we have to define the current working directory and then data folder within it. For that we can use this code. So we have to create data folder, and then what we have to do is we have to collect the PDF to summarize, okay, from the given link here. So once it's done, what we have to do is we have to construct the file path for the downloaded PDF. For that, we can just create the file path using the PDF URL, and then what we have to do is we have to use the request to download the PDF files. So once we downloaded, we have to ensure the response is successful using the code here, and then write the content of the file to the PDF file that we have created. Okay. So if you see, it's just downloaded in the data folder like here. The file, what you do is we have to extract the text from the PDF file. Okay. For that, we can use PDF reader. So let's use PDF reader to read the text from the PDF. We have pre-processed the file and the file is ready now. So let's apply the first method, which is stuffing. Stuffing is the simplest method to pass data to the language model. So it stuffs text into the prompt as a context in a way that all of the relevant information can be processed by the model to get what we want. So in LangChain, we can use stuff document chain as the part of load summarize chain method. So what we need to do is like setting the stuff as the chain type of your chain. Okay. So first we have to design the prompt for the stuffing. So let me create the markdown to identify like we are applying the method 1, which is stuffing. So we have to design the prompt. If you see here, we have the simple prompt and we prepared the prompt template with our input variable and then simple prompt that we have created. Okay, let's run it. Then we have to initiate a chain using stuff method, and then we will be processing only few pages for the first time. Okay, in the stuff chain variable we load summarize chain with LLM, and as I said, like we are mentioning chain type as step and then we are sending the prompt as well. Okay, so for the testing purpose we will be taking first 4 pages of the PDF. Okay, let me copy the link and let me go here. So if you see here, we have 40 pages in this PDF. Okay, so what we have to do is we will be taking first 4 pages, which covers the large language model overview and then what is large language model and about its parameters. So we'll be using the first 4 pages here. Let's print and see what this 4 pages covers. Okay, so as we saw there, like it just covers the first page and then overview and then what is large language model and its parameters. Okay, so let me invoke the step chain. Okay, for summarization. For that we have to use step chain run with the pages that we want. Okay, to summarize. So what it will do is it will invoke the model, I mean our OLLM or Mistral model, and try to summarize these 4 pages. Yeah, it started to stream the output. If you see here, it just rendered the output in an organized way with bullet points as we mentioned in our prompt template. So it looks good. Okay, so like stuffing method is a way to like summarize text by like feeding the entire document to the large language model in a single call. So this method is more advantageous, but it comes with pros and cons. So the stuffing method only requires a single call to the LLM, and which can be like faster than any other method that require like multiple calls. For example, like if you take MapReduce or refine, it needs like multiple calls to the LLM, but stuffing method will be sending a single call to the LLM to summarize the text. So when summarizing the text, the LLM has the access to all the data at once, so which can result in a better summary. But LLMs have a context length, okay, so which is the maximum number of tokens that it can be processed in a single call. So if the document is like longer than the context length, the stuffing method will not work. So also the stuffing method is not suitable for like summarizing large documents, as it can be like slow and may not produce a good summary. So let's explore other approaches to help deal with having like longer text than the context length limit of the LLMs. Okay, second method is MapReduce. Okay, so the MapReduce method, which implements a multi-stage summarization. For example, if you see here we are in the map stage, and so this stage is called as a reduce stage. So it is a technique for summarizing a large piece of text by like first summarizing smaller chunks of the text and then combining these summaries into a single summary. Okay, so in LangChain you can use MapReduce document chain as a part of like load summarize chain method, and what you need to do is like setting your MapReduce as a chain type. And let's go back to our practical implementation of this method. Okay, so where in our example earlier I show like 40 pages of PDF document, and we used like stuffed method to summarize it. Okay, so as you see here, so to test the MapReduce method, we will be using another PDF. Okay, let's do the same as we did for the previous PDF, and try to download it and then write it in the file path. Okay, so let's explore the PDF that we have downloaded. Okay, so this PDF is all about like large language model beginner guide, and then we have 7 pages in it. Okay, so once it's done, what we have to do is we have to convert. So we have to extract the text from the PDF. Let me extract the text as we did earlier. So it's done now, and then we have to design the prompt for the MapReduce chain. Okay, so with LangChain, the MapReduce chain breaks the document down to like set of chunks, and then it runs the initial prompt, okay, which is the map prompt, which will generate the summary for the chunks, and then we will use another prompt which is combined prompt, which what it will do is it will use all the summary of the chunk to generate the final summary. Okay, so we need two prompt here. So let's define our two prompt for MapReduce. So this one will do the summary of the chunks and the which is in the map stage, and then we have another prompt. What it will do is it will convert all these summaries to a final summary in the reduce stage. Okay, so let's define the prompt template. So once we generated our prompt template, we have to generate summaries using MapReduce method. For that we can use load summarize chain as I said earlier. So we have changed like chain type to MapReduce, and then we have feed our map stage prompt and then also reduce stage prompt here. Let's run it. Then we can just generate the summaries using this chain. Okay, let's invoke the chain. It may take a few minutes to complete, as it will do like multiple calls to LLM for each chunks to generate the intermediate summary, and then feed all these summaries to the LLM to produce the final summary in reduced stage. Okay, so now it's done. After summaries are generated, so you can just validate them by organizing the input document and associated output in the pandas data frame. So let's do the validation, where we will be using the map reduce output from our previous cell, and then we will be taking input documents and intermediate steps. From there we will be taking the metadata from the document like file name, file type, and then page number, and then we'll be taking the page content, that is chunks in our case, and also taking the output and then putting it in the column. So once it's done, we will be doing a simple preprocessing to convert it in the better format, and then just sorting it out with the file name and the page number. Let's print it out. Let me open it in the text editor. So if you see, we have the context and the simple summary which is generated for the context. So context here is the chunk, and then simple summary would be our precise summary, the number, and then the file name. Okay, so this is the output for just the third index. Okay, so with MapReduce method, the model is able to summarize a large paper by overcoming the context limit of stuffing method with parallel processing. And however, MapReduce requires multiple calls to the model to generate intermediate summary, and then potentially losing the context between the pages. Okay, so to deal with these type of challenges, we can try another method to summarize the multiple pages at a time. Okay, so the third method is refine. Okay, so the refine method is an alternative method to deal with larger document summarization. So it works by first running an initial prompt on a small chunk of data, generate some output. Then for each subsequent document, the output from the previous document is passing in along with the new document, and then the LLM is asked to refine the output based on the new document. So for this, in LangChain, we can use MapReduce document chain as a part of a load summarize chain method. So what you need to do is you can setting the refine as the chain type in your chain. Okay, so let's test the refine method for the same PDF that we saw earlier with this one. So for the prompt design for the refine chain, which occurs two prompt as MapReduce one. So the question prompt to generate the output of for the subsequent task, and then refine prompt to refine the output based on the generated content. Okay, so let's declare these two prompts. Okay, so the first prompt will provide the summary for the text, and then in the refine stage we will be creating the concise summary using the previously generated summary with the new input document. Okay, let's run it. So, and then we have to generate a summary using a refine method. So for that, you should initiate the summarization chain using refine chain type. So if you see here, we are giving chain type as refine, and then question prompt as our first prompt, and then refine prompt with our second prompt. Let's run it. And then now we have to use the summarization chain to summarize the document using the refine method by calling the refine chain here. Okay, with all the pages from the PDF here. Let's run it. So now it's done. It took around 3 minutes in my machine. Yeah. So once we done with this step, let's validate it as we did for the MapReduce. Okay, we'll be doing the same thing. Okay, we will use the refine output from the previous cell, and we'll be taking input document as an intermediate step. Okay, as the output, and we will be loop through and we will be generating the list of refined data. It includes the metadata like file name, file type, file page number, and then chunks, and then finally the output, I mean the intermediate step output, which is concise summary. Let's run it. We'll be processing the final refined data list and then putting it in the data frame, and then sorting it based on the file name and then page number. Let's run it. And then we will be seeing just the third index from the data frame. So let me go here to the text editor. If you see, here is the context, and then the simple summary would be the intermediate summary, and the page number is 3, and then the document name. So in short, like the refined method for text summarization with LLM can pull in like more relevant context and maybe less lossy than MapReduce. However, it requires like many more calls to the LLM than stuffing, and these calls are like not independent, okay, meaning they cannot be parallelized. So additionally, there is some potential dependency on the ordering of the document. So latest document, they might become more relevant as this method suffers from recency bias. So hopefully in this notebook you learn about like different techniques to summarize long documents with LangChain and Mistral. And what you have seen in this notebook or like only some of the possibilities you have. For example, there is another method which is called like map re-rank method, which involves like running an initial prompt on each chunks of data, which not like only tries to complete their task but also gives a score for like how certain it is in its answer or output. So the responses are then ranked accordingly to this score, and then highest score will be written. So that's it, guys. I just provided the resources that we used in the tutorial in the description below, and thanks for watching. See you all in our next video. Bye bye.